specific concepts you want me to explain, do let me know. We will quickly just get started with waves. Think the basic difference between mechanical waves and EM waves. Mechanical waves require a medium. EM waves don't. You travel even through vacuum. Transverse and longitudinal waves. So sound is a longitudinal wave. Oscillation is in the direction of propagation. And as you know, the others are transverse waves. So waves on a string, waves on water, light, these are transverse waves. Longitudinal waves depend on the Bulk's modulus, Young's modulus, because it opposes compression, whereas transverse waves depend on the shear modulus or surface tension or tension because they oppose a change in shape. Okay, the tighter a wire, the less it would prefer being distorted from that straight line shape that it has. So these quantities, shear modulus, surface tension, and tension, they play a role in transverse waves. Solids, as you know, can have transverse and longitudinal waves. Liquids can have only transverse waves on the surface, okay, but otherwise they cannot have any transverse waves through them because they don't have any shear modulus. But all of them have longitudinal waves, as you know. Sound travels through all of them. Wave equation, I think हाँ ये काफी ये थोड़ा important था. Basically when a wave ka equation is given to you at the origin as a function of time, when you're told how a particle at the origin varies as a function of time, तो वहां से वो point उठा के अगर तुम्हें wave equation लिखना है, the formula is, if that's f of t at the origin, then the wave becomes f of t minus, in fact it's f of t minus x by v if the wave is moving along positive x, and is f of t minus, it's f of t minus x by v if the wave is moving along positive x, is f of t plus x by v if the wave is moving along negative x. Okay, and that's the characteristic equation of a traveling wave. So you can have questions like this, like we did in class, x equal to 0 पे y as a function of t दिया है, and they can ask you कि इससे wave equation कैसे बनेगा. And they also tell you the velocity. So basically, if it's moving towards negative x, f of t, जिधर भी t है, t की जगह t plus x by v डाल दो, and अगर positive x की तरफ जा रहा है तो t minus x by v डाल दो. ठीक है. Shape of the string basically refers to y as a function of x. So at t equal to 3, wave equation में 3 डाल दो, t के जगह 3 डाल दो, and you get the shape of the string. You get y as a function of x. So this is how we would arrive at the wave equation given how a particular particle is oscillating. On the other hand, if you're given how the string ka shape looks like at a specific instant of time, for instance t equal to 0 में string का जो shape है, क्या shape है, what function of x, how does y vary with x. So if they give you that at t equal to 0, and with that you want to get the wave equation, then the formula is, if it's moving along positive x, the wave equation is f of x minus bt. अगर t equal to 0 पे f of x है, तो general time पे f of x minus bt होगा. And अगर wave negative x की तरफ जा रहा था, तो f of x plus bt होगा. Okay, these are things you should be aware about. So again, there's some practice questions on this. I would suggest go through these, attempt these questions. All the in-class questions, attempt them. That'll be a good way of revising. If the shape of the string is f of x at t equal to t naught instead of t equal to 0, then the formula is f of x minus v t minus t naught. अगर t equal to t naught पे shape दिया है, तो wave equation becomes f of x minus v t minus t naught. And similarly, अगर displacement, origin का displacement f of t देने की जगह x equal to x naught पे displacement वैसा दिया है, then f of t minus x by v की जगह x minus x naught by v होगा. So please do revise this section and see if you are familiar with this. Okay, so that's one thing to be mindful of. but उसके आगे फिर your wave equation में we find कि if we differentiate y with respect to time, we get v square dou y by x square. Double derivative of y with respect to time is v square into double derivative of y with respect to x, and this is the characteristic equation for any linear one-dimensional wave. This will be satisfied by any one-dimensional traveling wave. और यही equation single derivative में looks like this, and this is useful sometimes when we want to find a link between particle velocity and the wave velocity. So v is wave velocity, dou y by dt is particle velocity at a particular x coordinate, and dou y by dou x is the slope of the string at that x coordinate. So particle velocity is minus v into slope, and कभी-कभी इसमें सवाल आता है, and there are some examples which you can attempt on that. Now quick theory का review कर रहे हैं हम लोग. Traveling sine wave in one dimension, you have frequency, time period defined exactly the same way. This is a new term for us. Frequency and time period was similar to SSM. यहाँ पे k is omega by v. Okay, so omega is the angular frequency of the wave. K is your wave number, so k is omega by v. K is basically the coefficient of x in that wave equation. Okay. ओमेगा एंड टाइम पीरियड के बीच में सेम रिश्ता है जो एसएचएम में है. वेवलेंथ लैम्डा relates to k in this manner. K is 2 pi by lambda. K is 2 pi by lambda. Okay. And another useful relation is k is rate of change of phase with respect to distance. So omega was delta phi by delta t, rate of change of phase with respect to time. K is rate of change of phase with respect to distance. So it's delta phi by delta x. So that also comes out to be omega by v. Velocity is lambda by time, velocity is f lambda, omega is v into k. These are all equations you should be familiar with. Okay. फिर हाँ, ये important है. Whenever you're given a wave equation, this formula in a way sums up how you would interpret omega k and the velocity ka direction. So if you're given a wave equation, the idea is whichever form they write the equation, the coefficient of time, okay, uska magnitude will be omega. So kabhi just watch out, kabhi time का coefficient कुछ brackets के अंदर होगा और bracket के बाहर भी कुछ चीज होगा. Don't forget to multiply them. ठीक है. कुल मिलके time का जो coefficient है, sin something of t लिखते वक्त time का ultimately जो coefficient है, when everything is multiplied, time का जो coefficient है, that is the magnitude of omega. उसका mod लोगे तो that will give you omega. Similarly, x का coefficient, net coefficient जो भी होगा, that will give you the magnitude of k. Okay, so ignore the signs, you'll get omega and k. Omega and k are always positive. And to get the direction of velocity, the basic hint is when those coefficients are of opposite signs, it's moving along positive x. And when those coefficients are of the same sign, it's moving along negative x. Okay. So जैसे यहाँ पे 2 and -3, opposite signs moving along positive x. And magnitude के लिए omega पहले निकाल दो. Omega is mod of t का coefficient, k is mod of x का coefficient, ठीक है, and omega by k is v. So 3 by 2 is v. All right, so that's how we can interpret velocity from a wave equation. Okay, so again, these are some straightforward questions. Please do try them. फिर wave ka velocity, if you remember, we do this derivation. You of course don't need to as such derive things in the exam, but then the way this is derived is similar to that standard circular motion question. Ring में tension कितना होगा when a ring is rotated, तो इसका derivation थोड़ा वैसा है. So do make sure that you're at least familiar with that derivation. How do you find the tension in a rotating ring? Again, that comes up in many chapters. Finally, our result is that wave's velocity is root t by mu, and this is the velocity with respect to the string. String के frame में ये velocity दिखता है. String खुद अगर एक गाड़ी में है and it's moving, then accordingly the wave's velocity will be even greater. Okay. Again, so a question like this, simple questions. I think ये वाला थोड़ा अच्छा question था. Make sure you try this. इसमें वो relative वाला फंडा आ जाता है. Wave का एक motion है, but on top of that ये string, because it's in a pulley block system, string में tension आ जाएगा. Tension से velocity wave का मिल जाएगा, but वो wave का velocity string के relative मिलेगा. Now, because these blocks are not of equal weights, you can see that the string itself is going to move from left to right. The string is also going to move. तो जो wave velocity आता है वो string के respect में आता है, या जो भी wave का motion हो रहा है वो string के motion के ऊपर हो रहा है, on top, in addition to that हो रहा है. And that is something you have to consider in this question. So please do attempt all these questions जो मैंने in class दिया है and get it done with. Waves as such is a scoring chapter. It's not as conceptually deep as mechanics or electromagnetism. So make sure this is one area you can rely on, be confident of. Yeah, this is still that question. Remember this question, ये इसमें टेंशन निकालना होता है, तो टेंशन figure out tension नीचे से ऊपर जाओगे तो increases with x. Tension is actually mgx by l. Standard question है, be comfortable with this. Mu is m by l. यहाँ से velocity actually as a function of x from the bottom of a heavy rope is root gx. And if they want, they can ask you to find time. Given velocity is a function of x, they can ask you to integrate and find time taken for the pulse to reach up, which is done in the second and third part. Okay, I think this page just basically this is just a summary of how to choose different differential equations. So एक बार just since we are here, एक बार याद दिला देता हूँ. If you have velocity as a function of time, then the best choice, then you have no choice but to use v is dx by dt, and that'll give you dx by dt as a function of time, which will give you x as a function of time. Okay, that's how you get x. That's how you integrate that. Velocity is a function of x. You have to use again v is dx by dt, and you get dx by dt as a function of x, and usko rearrange करके you can get again x as a function of time. Yeah, time as a function of x, but basically a relation between them. Acceleration, on the other hand, if you have acceleration as a function of time, a equal to dv by dt डाल दो, तो you get a differential equation in velocity and time, integrating which will give you velocity as a function of time. If you have a as a function of x, use a is v dv by dx, which gives you v dv by dx is f of x. Integrating that gives velocity as a function of x. There's no other option. You can't do anything else in these two cases to integrate and find the answer. On the other hand, when you have acceleration as a function of velocity, then you have two choices. You could use dv by dt as a, so that gives you a differential equation in velocity and time, जिससे velocity is a function of time निकलेगा, or you could use a is v dv by dx, जिससे velocity is a function of x निकलेगा. All right, so that was just I believe as on a side note, but the idea is basically make a substitution bearing in mind what you have and what you want, right? And use one of these three, in fact, these three differential equations. तीन choice है, तीन का choice है. And before you solve a differential equation, it has to be only in two variables, because there are only two sides, right? So you have to ensure कि it has to be in two variables. एक तरफ वेलोसिटी एक तरफ टाइम, या एक तरफ वेलोसिटी एक तरफ एक्स। वैसा सोच के यू विल कम टू नो विच वेरिएबल टू यूज। जैसे यहाँ पे हम वी डी वी बाई डी एक्स यूज नहीं करेंगे, वरना वी एक्स और टाइम तीन चीज रहेगा, सो वी आर लेफ्ट विथ नथिंग बट डी वी बाई डी टी। ओके, दैट्स हाउ दैट वर्क्स। नाउ एवरेज वैल्यू, एवरेज वैल्यू तो डेफिनेशन काफी इंपॉर्टेंट है, यू माइट हैव सीन इट इन एसी एज वेल। एवरेज वैल्यू का डेफिनेशन है एरिया सॉरी इंटीग्रल एफ ऑफ एक्स dx, यानी कि एरिया अंडर द ग्राफ अपॉन इंटीग्रल dx, change in x. Okay, so area under the curve from during that interval upon that interval length. Okay, जैसे average velocity is area under velocity time graph upon the time interval, displacement by time. वैसे average value of any function is integral f of x dx from x initial to x final upon integral dx, which is basically change in x. इसमें useful relation result that we see is cos square x and sin square x का area is half. Okay, most of the times you have to find this average value, area nahi, average value is half. So most of the times you need to find this average value. It will typically be for a function having cos square x or sin square x in several places, यहाँ पे AC में वगैरह. Just remember कि उसका average value आधा होता है. कैसे? क्योंकि दोनों by symmetry, दोनों का graph similar है. They just shifted, so they should have the same average. On top of that, they add to 1. So the averages also should always add to 1. So both need to be half. Power transmitted, power is energy per unit time, intensity is energy by area by time, and energy density is just energy by volume. Power intensity और area के बीच में relation ऐसा आएगा ISP by A. ठीक है, always be aware of that derivation. So हम T time में we allow energy to flow, and moving at velocity v, energy reaches a max distance of vt. So in that entire interval, जो starting में निकला वो एकदम दूर vt distance दूर पहुंचेगा from this from this cross sectional area, but जो just interval के end में enter किया वो लगभग इधर ही होगा. So it's safe to say that all the energy passing through that cross section in time t now lies in a cylinder of this volume, right? So energy crossing is power into time, okay? And energy density is energy, that same energy is contained here upon volume, and that volume is Vt into A. So power into time by Vt into A gives you an energy density is power by velocity by area. And since intensity is by definition power by area, energy density is also I by V. Okay, it's I by V, intensity by velocity. Based on that, we get the formulas for instantaneous power, intensity, and energy density. They are in front of you. But more important than these formulas are the formulas for average power, average intensity, and average energy density. And basically, एक याद कर लो, at least power का याद कर लो, half mu v a square omega square. Power का अगर याद कर लिया, फिर power in upon area will give you average intensity. तो intensity वहां से आ जाएगा, and then intensity by velocity will give you energy density. So if you remember those conversions or those definitions, you can switch from one to the other. And also अगर तुम्हें same चीज का instantaneous values का formula चाहिए, instantaneous power being transmitted, instantaneous energy density, ये अगर ऐसा ऐसा कुछ चाहिए, then all you need to do is replace half by cos square phase, because the original function had cos square phase. Half is just its average value. Replace half by cos square phase to get instantaneous P I N E D. Okay. Superposition of waves is very similar to adding SHMs, which is revised SHMs yesterday, जैसे SHMs को ऐड करोगे वैसे ही waves को ऐड करोगे by treating them as vectors. Same sign convention, sin omega t minus kx. Stick to one. Sin omega t minus kx is along positive x. Cos omega t minus kx is along y, positive y. फिर minus sign is along negative x. Minus cos is along negative y. So stick to one convention, and then उसके हिसाब से plus phi plus phase difference is basically found when you rotate in the anti-clockwise direction. And a negative phase difference means rotating in the clockwise direction. Okay. तो वो important है, superposition of SHMs. Do practice these questions. फिर constructive and destructive interference. तो constructive interference के लिए we see कि basically the phase difference should be an even multiple of pi. It should be basically a multiple of 2 pi. That's for constructive interference. Constructive interference where they just simply add up. It's like two vectors in the same direction. So resultant amplitude is A1 plus A2. Destructive mean should be an odd multiple of pi. So that's when the resultant amplitude is mod A1 minus A2. It's basically the difference of the two. It's like adding two vectors in opposite directions. Okay, so interference between two pulses going in opposite directions. So if the pulses are upside down, they cancel each other perfectly. If they are both upright, they add up. And with this, we go to the fact that when you have reflection from a free end, so reflection from a free end, there is no inversion, there's no phase change. Okay, there's no sudden phase change, there's no inversion. And you can imagine reflection from a free end as an imaginary upright pulse coming from behind the pole, and it's upright. Okay? And this flows over to that side, and that flows into this side. You can just imagine it in that manner. That's how it actually behaves throughout this entire motion. The reflection from a fixed end, on the other hand, causes an inversion. Okay, and so that can be visualized as an imaginary inverted pulse coming in from behind the pole. Okay, so this flows into that, and that flows into this. And for a brief moment, you will even see that the shape is flat. Then afterwards, you see that it has been inverted. Okay. इनमें इस वाले में reflective pulse का equation, you will use the same amplitude. Okay, reflection from a fixed end, same free end, same amplitude, only the same k, same omega. You're in the same medium. The only difference is minus की जगह plus. पहले माइनस साइन था, मतलब पॉजिटिव एक्स की तरफ जा रहा है. अब प्लस है, मतलब वो नेगेटिव एक्स की तरफ जा रहा है. इसमें ये तो प्लस हो गया टू टेल यू कि वेव उल्टा जा रहा है, वापस रिवर्स डायरेक्शन में जा रहा है. बट ये माइनस से हो गया टू टेल यू दैट द वेव गेट्स इनवर्ट. ओके, एंड यहाँ पे आई थिंक आई गिव वन वेरी इंपॉर्टेंट पॉइंट इन ऑल दीज रिफ्लेक्शंस. जब भी होता है, basically just change the, if you want a wave to equation to suddenly represent the same wave going in the opposite direction, just change the sign of omega. Don't change the sign of x, because that will change the entire function as immediately. Just change the sign of omega. तो इसका मतलब with time अब आगे जाने की जगह वो उल्टा जाएगा. And there's a question on that. Again, you should try that. फिर reflection and transmission of a wave as it goes from one string to another string. So basically, one important result you get is contrary to our first instinctive थॉट की ऐसा लगता है कि हो सकता है इंसिडेंट रे प्लस रिफ्लेक्टेड रे, सॉरी इंसिडेंट रे प्लस ट्रांसमिटेड रे का एरिया बिकम्स रिफ्लेक्टेड रे का एरिया नहीं, एम्पलीट्यूड बिकम्स रिफ्लेक्टेड रे का एम्पलीट्यूड, रे भी नहीं, इंसिडेंट वेव एंड ट्रांसमिटेड वेव का एम्पलीट्यूड बिकम्स रिफ्लेक्टेड वेव का एम्पलीट्यूड, ऐसा लगता है लोगों को, बट दैट्स नॉट ट्रू. दैट्स एनर्जी व्हिच शुड बी कंज्यूम्ड. यहाँ पे ऐसा नहीं है कि दो चीज का एम्पलीट्यूड अलग था, मिलने पे एम्पलीट्यूड उनका एडिशन होना चाहिए, नहीं, they don't add like that, they don't add as scalars. The idea on the other hand is तुम्हारा ट्रांसमिटेड वेव का एम्पलीट्यूड राइट हैंड साइड पे और लेफ्ट हैंड साइड पे दो वेव्स है साइमल्टेनियसली, एंड उनका रिजल्टेंट ऐसा ऐसा है, तो व्हेन यू ऐड देम अप देयर एम्पलीट्यूड एक्चुअली इक्वल्स द एम्पलीट्यूड ऑन द राइट हैंड साइड जो ट्रांसमिटेड वेव का है. सो विद दैट वी रियलाइज की the transmitted wave amplitude is incident wave amplitude plus reflective wave amplitude. That's an important equation. दूसरा power equation, power we can easily prove is basically proportional to k a square. ठीक है, mu v a square था, mu v को डाल दिया root t by mu, so power is root mu a square and k itself is proportional to root mu. ठीक है, k is proportional to root mu, so with that we get power is proportional to k a square. So now when you apply energy conservation, this is initial power is reflected power plus transmitted power, right? So the incident power is k square, reflected power is k ar square. Note k same है reflected wave के लिए क्योंकि वो same medium में है. Incident and reflected waves are the same medium. K is defined for the medium, okay? And k dash is and transmitted का हो गया k dash ad square. So k square is k ar square plus k dash ad square. So subtracting basically k square, ये basically इसको फिर आगे जब जाके derive वगैरह करेंगे, when you combine the two equations, the result we get is AR is k minus k dash upon k plus k dash a, and A transmitted is 2ka upon k plus k dash a, and finally you have that by the way, good way to check these values is free end के लिए mu is 0, it's as good as an infinitesimally light string, k dash is as good as 0, तो तब reflected wave का amplitude a आना चाहिए if it's a free end, right? Because it stays upright. On the other hand, if it's a if it's a fixed end, then the second part of the string, the string on the other side is so heavy that it almost hardly moves. Therefore, it will behave as a fixed end. Fixed end में क्या हो जाएगा? Mu dash is proportional to infinity. K dash is also mu dash tends to, as mu dash tends to infinity and k dash tends to infinity, you get AR tends to minus a, which was expected because for a fixed end there is an inversion taking place. Okay, so यहाँ पे वो algorithm sums it up. Please go through it. Your steps when you make any transformation is you first find k by looking at the coefficient of x. Okay, incident wave का k निकाल दो. Find k dash. Okay, use this correctly. Find k dash. K dash is proportional to root mu. Mu is linear mass density. Okay. फिर find AR using this formula and AT using this formula. Now that you have all of this, उसके बाद for the reflected wave, ये जो original equation था उसमें replace omega with minus omega because the reflected wave goes in the opposite direction. Make sure not to randomly replace k with minus k. That changes the function as well. Just replace omega with minus omega. Okay, and then replace a with ar and fair enough. So yr is ar sine kx plus omega t, yt is at sine k dash x minus omega t. The transmitted wave is still going along the same direction. तो यहाँ पे sign change कुछ करना नहीं है. The only difference is k is different. ठीक है? Because it's a different medium, so k is different. Okay. Okay, some examples on that for you to try. Phase difference between two waves is difference in omega t minus kx. So that will be omega delta t minus k delta x. So it's basically this equation दोनों मिलके बताएगा change in phase due to time and change in phase due to change in x. Okay. Standing waves. The standing waves you can see from the derivation ki when we combine two traveling waves, we get a standing wave. ये डिफरेंस इज स्टैंडिंग वेव में साइन के अंदर एक टर्म के अंदर सिर्फ एक्स रहेगा और एक और साइन टर्म के साइन या कॉस टर्म के अंदर सिर्फ सॉरी सिर्फ टी रहेगा. तो एक के अंदर सिर्फ एक्स, एक के अंदर सिर्फ टी. उधर साइन एक्स माइनस बी टी ऐसा टर्म्स रहता था, बट एक प्योर यहाँ पे प्योर एक्स प्योर टी का टर्म्स है. Resultant amplitude that you get when combining two traveling waves, okay, is is two standing waves at the same frequency. The resultant amplitude is basically 2a dash sine kx plus delta by 2 and cos omega t plus delta by 2. So that's the resultant wave equation. The resultant amplitude, mind you, is twice of that of the incident and the reflected amplitudes. Okay. Okay. Yeah. Now, for a standing wave, lambda and time period are defined in almost the same way, although technically this does not move along the, it does not propagate. Still, you can define a velocity for it, although it's not gonna, there's no traveling wave in this, there is no wave velocity as such, but you can still define v for it, and v is basically going to be just lambda by t, yeah, f into lambda. So you can theoretically define v for that string in that state of tension. Now these points are called as nodes, as you know. Okay, and these the other points are called as antinodes. Okay? That's your standing wave. Standing wave में फिर एनर्जी का बात थोड़ा important है. Standing wave में first thing is you do not have any transfer of energy. Energy is more or less locked between the region, in the region between two nodes. The reason for that is even if this portion oscillates, the work done on it by the surroundings will be zero, क्योंकि surrounding um, work done on it by the adjacent portions will be zero because the point of contact is not moving. Okay? So energy is basically locked between two nodes. And that energy, however, changes in form from potential energy to kinetic energy. Okay? When they're all flat, there is no stretching the strings, there's only zero potential energy and maximum kinetic energy. इसमें याद ध्यान दो कि velocities are in opposite directions between adjacent nodes. यहाँ पे नीचे, वहां पे ऊपर, यहाँ पे नीचे, वहां पे ऊपर, वैसा. ठीक है. ऑन द अदर हैंड, अब ये जो काइनेटिक एनर्जी है, जो मैक्स है, ये फिलहाल ज्यादा सेंटर के पास लोकेटेड है. ठीक है, because the parts closer to the nodes are hardly moving. On the other hand, when this energy reaches the top, when the particles go to the extreme position, तभी तभी क्या होता है, तुम्हारा पोटेंशियल एनर्जी फिर मैक्स हो जाता है, काइनेटिक एनर्जी जीरो हो जाता है, because they are going to stop at the extreme position. And at the extreme position, your energy is stored, is concentrated around the nodes, because the nodes undergo maximum stretching, as you can see by this diagram. Okay, so in the extreme position, the nodes are stretched the most. So basically क्या होता है in a standing wave? Energy relocates. As is about to go down, your energy is more towards the center and it's kinetic in nature. When it reaches there, your energy is more or less static, rather potential, and it's potential energy, and it's closer to the nodes. As it comes back, it's again at the antinode kinetic. As it goes to the extreme position, it's again closer to the nodes, and it's potential. So energy is converting from one form to another in an oscillation, and also it is changing its locality. So within the region between two nodes, it's moving away from the antinode back to the antinode. Yes, sir. But it's still locked between two nodes. Okay. Then finally, you have strings with both ends fixed, very similar to an organ pipe ka kahani. If the string ka dono ends are fixed, then this is the this is the equation of our standing wave. But basically, what we finally get is, so our frequency comes out to be n by 2l into root t by mu, where n can be any natural number. So you get different modes of frequencies. Finally, the best way to remember when the string has both ends fixed is to remember how the subsequent um, modes of vibration look. So the first mode looks like this, which is one hole. The second mode looks like it has two holes, and so on and so forth. So I think a good word is loop. So the nth mode looks like it'll have n loops. Okay, it looks like it'll have n loops. So if a mode has n loops, okay, looks like it has n loops, the nth mode. और n loops के लिए जितने loops हैं, I repeat here, yeah, तो जितने loops हैं, है ना, फिर वेवलेंथ अकॉर्डिंगली, अच्छा वेवलेंथ कैसे लिंक करेंगे, तो हम बोलेंगे चलो लेंथ ऑफ दिस एंटायर स्ट्रिंग इज द लेंथ ऑफ n loops, and one loop itself is half of a wavelength, because a wavelength is two loops long. So one loop is lambda by 2. So if L is n loops and one loop is lambda by 2, that tells us that L is n lambda by 2. Here lambda is 2L by n. You can say L by n is one loop, so lambda is twice of that. Lambda is 2L by n. Okay? तो ये रिश्ता आ जाएगा based on the number of loops. If n is 3, lambda will be 2L by 3. Accordingly, frequency is velocity by lambda. Okay? So velocity के लिए root t by mu use करो, because the velocity that it would have had the wave been traveling. So root t by mu use करो, and n तो बस f comes as a function of n. So fundamental frequency इसमें is root t by mu by 2l when n is 1, and that fundamental frequency is called as the first harmonic. Then the next frequency is called as the first overtone. उसके बाद is the second overtone. तो हर overtone में एक एक loop add होते जाता है, हर overtone में एक एक loop add होते जाता है, and both ends fixed में ऐसा होता है कि each overtone is a so like the first overtone is like the second harmonic, because इसका frequency is twice the fundamental. Third overtone, second overtone is like the third harmonic, उसका frequency is thrice the fundamental. तो इसमें सारे integral multiples of fundamental आता है, जिसके कारण इसमें सारे harmonics exist right from the first. In fact, all natural number harmonics exist when both ends are fixed. On the other hand, when one end is fixed, long story short, you get to see this as the fundamental mode of vibration. इस mode में lambda is clearly 4L, ये आधा लूप, एक पूरा लूप 2L, लैम्डा दो लूप के बराबर, तो एक लूप 2L lambda 2 loops, so lambda 2 into 4L. Okay, so L is lambda by 4 for the most fundamental mode of vibration in this, making the frequency 1 by 4L root T by mu. अब इसमें as you look at subsequent overtones, what you'll find is you keep adding one loop. So now 1.5 loops are equal to the length. Okay, so 1.5 loops are equal to the length. The length is 1.5 loops, और loop के जगह lambda by 2 डाल दो. The length is 3 lambda by 4, and accordingly lambda is 4L by 3, and accordingly इसका frequency आ गया 3 by 4L root T by mu. So the immediate next mode of vibration when one end is free and one is fixed, the immediate next mode has a frequency thrice the fundamental. उसके बाद वाला has a frequency 5 times the fundamental, which is why only odd multiples or odd harmonics in that sense exist for this type of vibration. Okay, and तुम्हें general result निकालना है तो निकाल सकते हो, like in general इसमें the other day somebody was asking something, इसमें confuse मत हो जाओ. Like some ask me, sir, should we take 2n plus 1 or 2n minus 1? They ultimately mean the same thing. They ultimately mean the same thing. It's just that both represent odd numbers. It's just that if you take 2n plus 1, then you have to start n from 0 to get your first odd number. And if you take 2n minus 1, you have to start n from 1 to get your first odd number. Okay? That's it. But basically, it's just representative of odd numbers. In this, you'll always have an integer plus 0.5 loops. There'll always be half a loop in the end. So if there are n.5 loops, L becomes n.5. n.5 is 2n plus 1 by 2 into एक loop is lambda by 2. वहां से lambda आता है 4L by 2n plus 1. Okay? So n.5, this is 0.5. तो n को 0 डाल दो तो 4L is lambda. This is 1.5, n को 1 डाल दो, 4L by 3 is lambda, and so on and so forth. I hope in general you guys find waves easy. Okay, wave optics. By the way, waves में कुछ specific doubt पूछना है. You saw any good question while solving any paper, please just post in the group. We can discuss that. तब तक एक बार quickly wave optics भी देख लेते हैं. So light is an electromagnetic wave. You have all these same equations. Time is 2 pi by omega, lambda is 2 pi by k. Velocity of light c is f by f lambda, या lambda by t, या omega by k. Same. Light is made up of an electric field and a magnetic field oscillating perpendicular to each other and also perpendicular to the direction of propagation. It's therefore a transverse wave and an electromagnetic wave. फिर effect of refractive index. So basically when light goes from one medium to another medium, frequency, time and omega never change. They are always constants. Okay, so in fact color is a property of the frequency more than wavelength as such, because its identity lies in its frequency. Frequency is always the same. Wavelength, as you go to different media, the value of that wavelength changes, but frequency never changes. फिर यहाँ पे you can follow the logic कि refractive index is inversely proportional to velocity. Velocity is directly proportional to lambda because frequency is not changing, and lambda is inversely proportional to k. So long story short, k is proportional to mu. Okay, wave number is proportional to mu. So as I enter a medium जिसका refractive index mu है, velocity v by mu हो जाएगा, lambda by mu हो जाएगा, वो important है, और k into mu हो जाएगा. Okay? k into mu हो जाएगा. फिर so when you travel along a particular path in vacuum, if you travel x distance, phase changes by k times x. But if you travel the same distance in another medium, जिसका refractive index is mu, तब phase changes by k times. In fact, k dash x is medium का k into x, और इस medium का k is mu k. So mu k into x, and we can effectively say कि अच्छा traveling x in this medium is similar to traveling mu x in vacuum, because mu x in vacuum के लिए भी part difference k into mu x आएगा. So if you remember, this is like when when light travels in another medium, it's almost like it gets extra points for covering the same distance. It travels x distance, but that's the same as traveling mu x distance in vacuum. It's like it's kind of like you ran through water, which is a lot more difficult than running through air. So because you ran through water, you lost as many calories as you would if you would have covered 10 times that distance in air, or something like that. So when light travels through a medium, travels x distance through a medium, it undergoes as much phase change as it would undergo had it traveled mu x distance through mu x distance in vacuum. Okay, so that's the idea. So x distance in a medium is like mu x in vacuum. ये basic idea है. फिर इसको use करके we can get optical part difference. So geometrical part difference, as light goes from one point, comes from two places to a point, the geometrical part difference is just x1 minus x2 part difference between them. But the optical part difference में तुम क्या करोगे? तुम बोलोगे कि ये अब x1 जब इसके थ्रू चलता है, तो अब t डिस्टेंस वैक्यूम में चलने के जगह वो t डिस्टेंस एक मीडियम में चल रहा है, और वो मीडियम में t डिस्टेंस चलने के कारण कितना एक्स्ट्रा डिस्टेंस, कितना एक्स्ट्रा फेज जैसा फेज डिफरेंस आ रहा है, कितना एक्स्ट्रा डिस्टेंस के कारण फेज डिफरेंस आ रहा है. So traveling t distance in that medium is like traveling mu t in vacuum. So instead of t in vacuum, it is traveling as good as mu t in vacuum. मतलब कितना extra travel कर रहा है in vacuum just by passing through the slab? Mu t minus t. Mu t minus t. Okay, so that is an extra phase difference that you get, not directly by geometry, but by taking into account the fact that light may phase changes at a faster rate when you're moving in a different medium. So extra difference travel due to the slab is mu minus 1t. इतना upper slab extra travel कर रहा है. Okay, so your net optical part difference, if you're doing upper minus lower, will be x1 plus mu minus 1t minus x2. That's your phase difference. Now, I mean, there are practice questions. You can again try that. Practice whether your understanding of phase difference is good. So these questions, in class questions, should help you. This is another one. In fact, let me just check this once. हाँ, so इसमें ये क्या बताता है? It says कि light, तो light, so when you have basically when you have as we just saw, when a wave rebounds off a free end, there was no phase change, but when it reflected off a fixed end, there was a phase change. And the free end we saw was an extreme case of a light string, okay, where it goes faster, and the fixed end was like an extreme case of a heavier string where the wave becomes slower. तो वैसा ही यहाँ पे भी light के case में that free end will be like a rarer medium जहाँ पे light becomes faster, and the fixed end will be like a denser medium जहाँ पे light becomes slower. So when light passes from one media to another, like the transmitted pulse in waves never got inverted, वैसा ही यहाँ पे the transmitted wave never has a phase change. तो ट्रांसमिशन के कारण कोई फेस चेंज नहीं आता है. फिर लाइक उधर reflected pulse from a lighter free end वाला string suffers no inversion, वैसा ही light reflecting off a rarer medium undergoes no inversion. तो denser से rarer जाओगे और तब रिफ्लेक्शन होगा, यू रिफ्लेक्टिंग ऑफ अ रेयर मीडियम, तभी कोई इन्वर्जन नहीं होगा. ऑन द अदर हैंड, व्हेन वहां पे वेव पासेस फ्रॉम अ लाइट स्ट्रिंग टू अ हेवी स्ट्रिंग, तब इन्वर्जन होता है, या फिक्स टेंस से रिफ्लेक्ट होता है तब इन्वर्जन होता है. यहाँ पे जब ये डेंसर मीडियम से रिफ्लेक्ट होगा, when light from a rarer medium reflects off a denser medium, it undergoes a phase change of pi radians and an optical path difference of lambda by 2. मतलब तुरंत वो उल्टा हो जाता है. वहाँ पे extra, it's as good as it traveled an extra distance of lambda by 2. Okay, there was a sudden phase change of pi. So you may subtract, if you want, you may subtract lambda by 2 or add lambda by 2 for this ray while calculating the path difference. तो जैसे कि ये एग्जाम्पल में there are these two rays x1 and x2 और इनके बीच में पाथ डिफरेंस पूछा था. तो आइडिया क्या है, अपर माइनस लोअर अगर निकालना है, x1 माइनस x2 निकालना है, तो फर्स्ट एंड फॉरमोस्ट यहाँ पे दिस गाय, in addition to whatever is doing geometrically, it reflected from a denser medium over here, and reflecting from a denser medium made it walk an extra path difference of lambda by 2. On the other hand, this guy reflected off a rarer medium over there, which did not make it walk any extra path difference reflection के कारण. But this नीचे वाला guy, okay, he traveled an extra, in addition to whatever this guy did, he traveled an extra 2t distance through this medium, making his total path difference mu into 2t minus lambda by 2. Yeah, ulta, lambda by 2 minus mu into 2t. Alright, so ये सब path difference के लिए again just be aware, light of a denser medium undergoes inversion, तुरंत phase change होता है. You can maybe achieve that by adding lambda by 2 to the total path traveled, and when light reflects off a rarer medium, no phase change takes place. फिर some more examples. Please try these examples. Okay? Please try these examples out. Now, some more. Do try them out. That will be a good revision. Then constructive interference or destructive interference. So great. Constructive interference में if you remember, तुम्हारा electric fields add हो जाते हैं, ठीक है? They are in phase. Electric fields add up. In fact, उसके पहले intensity in general जब वो combine होता है, उसका formula काफी important है. And even if it's not at your fingertips, I would say it's very easy to derive it, because ये at least रटा हुआ रहेगा vector addition का formula. The electric fields, the actual wave is in the electric field, right? So that adds like a vector, electric field का amplitudes, and electric field के amplitude के square के proportional तुम्हारा intensity होता है. Okay, electric field के amplitude के square के proportional you have your intensity. And we have in fact seen this formula in EM waves, how intensity depends on E naught. Now, therefore अब इसमें क्या करो, जिधर भी E square दिखता है उधर I डाल दो, corresponding I डाल दो, और जिधर E दिखता है उधर root I डाल दो. तो E resultant square की जगह I resultant, E1 square की जगह I1, E2 square की जगह I2, E1 की जगह root I1, root I2. तो ये actually relation आता है between the resultant intensity and the intensity of two combining rays and the path difference between them. This is especially useful in YDSE as well. Sometimes YDSE mein, the two lights coming through the two slits have different intensities. And that'll be the case when the slits are open by different amounts. So because of the different intensities, they'll ask you resultant intensity kitna hoga ek point pe. So you'll need this formula, and you need it in several other places as well. Now this formula becomes a little better if I1 and I2 are equal, and if they are I0, this formula reduces to 4 I0 cos square delta by 2. So this is also pretty common. Okay, in fact, most of the times you may have waves interacting of the same intensity, especially YDSE में तो ये होता है. And यहाँ से दिख जाएगा कि when these guys are in phase, okay, and when I0 and I1 and I2 are the same, the max intensity you could get is 4 I0. The minimum you could get is 0. So talking about constructive interference, E max is E1 plus E2. Once you can say root I max is root I1 plus root I2. And you can say I max, मतलब ये तो रिश्ता आ रहा है I max के लिए. But if in that, if I1 and I2 are the same and they're equal to I0, then this relation becomes better. In the sense it becomes कि I max is 4 I0. I max becomes 4 I0. On the other hand, destructive interference में minimum E becomes E1 minus I2, E2, replace E with root I to get the corresponding relations for intensity. But if I1 and I2 are equal to I0, in this case, the minimum intensity comes out to be 0, which is quite evident from this formula. Okay. Again, page 11 has a question which I would leave it to you guys to practice these ones, 11, 12, see if you still are able to do these. Young's double slit experiment. So Young's double slit experiment mein, some of the assumptions we make is D is small in comparison to capital D, वगैरह वगैरह. And because of this, क्या होता है? We have coherent light passing through these slits and ultimately reaching different points of the screen. Sometimes there may be a part difference before they reach the slits. But let's say there is no part difference before they reach the slits. Then from here, by the time they reach the screen, an extra part difference that they will undergo is, let's say that is delta x. Okay, and I would suggest you remember delta x as xl minus xu. जो भी derived result है, let that be xl minus xu. Okay, because what we'll actually try to derive is we'll try to derive this length. कितना lower upper के comparison में चल रहा है. And that length by geometry comes out to be d sine theta. You know how it works. That comes out to be d sine theta. So d sine theta is the amount the lower ray is traveling in comparison to the upper ray. Okay. Sine theta becomes tan theta, which will become y by d. Okay. Tan theta will become y upon d. So delta x is approximately d sine theta, या dy by d. dy by d. Okay, and this is how much the lower travels in comparison to the upper ray. ऐसा याद करो, because then that will give you the right convention. Okay, y जब positive है, the lower ray is traveling more. xl minus xu positive है. y जब negative है, तब the upper ray is traveling more. So xl minus xu negative है. So because you take y axis upward, okay, this difference that we have written has to be xl minus xu. Okay, that's when the convention is right. फिर कंस्ट्रक्टिव इंटरफेरेंस के लिए इस पार्ट डिफरेंस को n लैम्डा से इक्वेट कर लो. तो dy by d को n लैम्डा से इक्वेट करोगे तो you get y as nd lambda by d. And similarly destructive के लिए you get it as n.5 d lambda by d. Okay, so you get you realize कि then you have bright fringes at every integral multiple of d lambda by d, and between all the bright fringes you have dark fringes. So d lambda by d then becomes an important term called as a fringe width. Okay, fringe width का formula is d lambda by d. Note it only depends on the slits ka size, distance, screen ka distance, and it depends on wavelength. So fringe width will not change when we add glass slabs in front of the slits. It only change as such if you move the screen away or do something like that, or if you change lambda by maybe immersing everything in water. Okay. And sometimes they talk about angular fringe width. I mean, so if this is fringe width and this distance is roughly d, angular fringe width will be omega by capital D. Angular separation. तो angular fringe width हो जाएगा lambda by d. Lambda by d. तो in fact इसमें ऐसा होता है कि where the maximas are formed, the angles at which along which the maximas are formed, they are typically fixed. Let's show you in a diagram. So your angular fringe width, which is omega by capital D, yeah, W by capital D, is lambda by small d. तो जहाँ पे मैक्सिमास बनने वाला था ना, those angles जहाँ पे फर्स्ट मैक्सिमा बनेगा, ठीक है, they are actually fixed. They are fixed. When you bring the screen close, I think zeroth maxima, central maxima यहाँ पे. So when you bring the screen close, the fringes will appear smaller. And when you take the same screen further away, the fringes will appear bigger. But the angular separation is fixed once lambda and the slit width is fixed. Yes, slit distance is fixed. All right, and exactly between them, you have your dark fringes. So, of course, this diagram shows कैसे तुम्हारे maximas किधर किधर बनते हैं और minimas किधर किधर बनते हैं. It's a uniform graph, and I think यहाँ पे mentioned delta theta is lambda by small d. इसमें, yeah, cool. So make sure this is, you understand, this is always, this is the central maxima. Central maxima is basically the maxima corresponding to a path difference of 0. Okay, so जो delta x है उसको 0 से equate करो, that gives you the central maxima. Central maxima doesn't necessarily have to be close to y equal to 0. Okay, it could be somewhere else, and there could be many more maximas between that and y equal to 0. Central maxima is defined as a point जहाँ पे delta x could 0. Okay, that's how the central maxima is defined. Okay. So that's the basics of YDSE. Again, you have good questions. I would suggest please try out these questions. So page 17 is a nice question. 19 पे मैंने थोड़ा वेरिएशन डाल दिया. इसमें क्या स्लैब्स डाल दिया. अच्छा, स्लैब्स के कारण क्या होता है? To incorporate that, make sure you're again aware is lower minus upper. So delta x is lower minus upper. उसमें dy by d आ जाएगा. इतना lower definitely चलता है. फिर lower ray और यहाँ पे T2 डिस्टेंस एयर की जगह स्लैब में चलने के कारण U2 minus 1 T2 चलता है. और सिमिलरली अपर एक्स्ट्रा mu1 minus 1 T1 चल रहा है. लोअर माइनस अपर गिनते वक्त ये ऑफ कोर्स डिफरेंस सब्ट्रैक्ट हो जाएगा. So this is delta x in such a situation. And then again, you equate, if you want to locate the central maxima, just equate delta x with 0, then you get the central maxima. So you can try this question. ये question basically वही था. Slabs डाल दिया तो central maxima locate करने के लिए delta x को 0 से equate किया, and we get the corresponding value of y. And इसमें basically they can say कि how many maximas or how many maximas cross the central line. So you need to see कि अच्छा पहले central maxima इधर था. Now the central maxima is there. So between the central maxima and this line I can see 3 maximas. Matlab 3 maxima, central maxima moved away from that line, and 3 maximas which were below that central line have gone up and crossed the central maxima. Okay, so basically ऐसा पूरा visualization का ही खेल है. Figure out how, in fact I think ये central line था और central maxima इधर है और ये 3 ने क्रॉस किया ऊपर से. सेंट्रल मैक्सिमा पहले उधर होना चाहिए था और इन 3 को लाइन के ऊपर होना चाहिए था. ये 3 ने सेंट्रल लाइन क्रॉस करके अब ये दूसरे साइड चले गए. तो दे कैन आस्क हाउ मेनी bright fringes cross the center line when we insert a slab. So before inserting the slab, see where the rays are, where the fringes are, and after inserting the slab, see where the fringes are. And for those questions also keep a track of the central maxima, see where it was before and where it was after. Sometimes there is a path difference before the splits, just incorporate that. जैसे अब यहाँ पे x, यहाँ पे there is upper rate कुछ ज़्यादा चल रहा है, our delta x is lower minus upper, so in addition to the d sin theta dy by d वाला term, we'll add this difference as well, lower minus upper, तो b minus a कितना lower चल रहा है in comparison to कितना upper चल रहा है before reaching the splits. ठीक है, तो ये सब मिला के मतलब धीरे धीरे they can add some variations, some complexities to YDC. Still, overall, it should be easily doable. Last variation they can add is they can put the entire thing under water. So when you put the entire thing under water, सारे slabs का refractive index mu से divide कर लो, because now what you need to do is you need to use the relative refractive index. सारे slabs का refractive index mu से divide कर लो, and सारे wavelengths को भी mu से divide कर लो, as we seen already. That's it. That's the only change. इस wavelength change के कारण fringe width change होने वाला है. So that's again, that's the idea. Try out that question. फिर एक और variation होता है effect of split width. Okay, and you can refer to HCD example 6, which mentions how that the amplitude, it just mentions it, doesn't tell how, but we'll use that. So the amplitude of the electric field, okay, of light passing through a slit, that is proportional to slit width. Okay, not slit distance, not small d, but एक slit का width, slit कितना wide है, that affects the amplitude. So intensity E naught के square के proportional होता है, तो intensity slit width के square के proportional होता है, क्योंकि HCV बता रहा है कि E naught is proportional to slit width. So basically then इसमें questions can come कि हमने जैसे एक स्लिट को डबल किया, इसको डबल किया तो इंटेंसिटी 4 गुना हो गया. इंटेंसिटी 4 गुना हो गया, तो फाइनली व्हाट आर द न्यू intensities of the bright and dark fringes? So from I naught they'll become 4 I naught and I naught. Okay, and then accordingly you can figure out what the dark and bright fringes look like. But एक चीज है definite इसमें, whenever such a thing happens, the bright fringes will become less bright. No, rather, sorry, the dark fringes will become less dark. The dark fringes will become less dark. The reason for that is because अब यहाँ पे minimum 0 नहीं आएगा. इसमें minimum intensity dark fringe में E naught करके exact 0 आता था, अब यहाँ पे 0 नहीं आएगा. इसमें minimum 0 नहीं आएगा. You can figure out the intensities using the formula we seen earlier. What's left? Colors का फंडा है. When you use white light which has all the colors in it, so they can ask what is the color closest to the central maximum, and you may feel कि अच्छा d lambda by d, जिसका lambda छोटा वो सबसे पास में बनेगा, है ना, उसका मैक्सिमा सबसे पास में बनेगा, तो यू मे थिंक कि वायलेट इज द नेक्स्ट कलर दैट इज सीन, बट इन रियलिटी दैट जस्ट मीन्स कि वायलेट का मिनिमा सबसे पहले बनेगा। तो अगर वायलेट का मिनिमा सबसे पहले बन रहा है मतलब रेड बन जाता है। The first color seen next to the central maxima is reddish, because violet has the smallest fringe width and it's uh, it hits its minima first, leaving predominantly red colors in the on the screen. Again, that's YDSC for you. Front of a single slit diffraction मेंस के पर्सपेक्टिव से ये सब इम्पोर्टेंट है। डी लैम्डा बाय स्मॉल डी की जगह डी लैम्डा बाय बी होता है इसमें। दैट्स इट। डेरिवेशन थोड़ा सा कॉम्प्लेक्स है, बट बेसिक आइडिया इज in a front of a single slit diffraction you have one bright fringe at y equal to 0, and then you have minimas at d lambdas by d, multiples of d lambda by b. तो 0 पे सेंट्रल मैक्सिमा और फिर मिनिमास एट प्लस माइनस d lambda by b. For all other fringes the fringe width is 1 d lambda by b, but for the central guy the fringe width becomes 2 d lambda by b, because there is no 0 d lambda by b पे मिलेगा, right? तो central maxima के लिए there's a and there's a wide fringe, and this is the brightest fringe. The other fringes are consecutively less and less bright. Okay. फिर question for you on that single slit diffraction. Front of a circular aperture diffraction is the same thing, same funda, बस इस बार slits होने की जगह instead of a central bright fringe there is a central bright disk. जिसका radius is, let's say इसका radius is फिलहाल 1.22 d lambda by b. Instead of d lambda by b, there is this number 1.22 that appears when we solve इसके relevant differential equation. Okay, 1.22 आता है circular चीजों के लिए. Consecutively तुम आगे जाओ 1.22 2d lambda by b 3d lambda by b, इन सारे जगह पे you will get minima, you will get circular rings जहाँ पे light is at a minimum. जैसा 2d lambda by b पे you get a dark fringe, वैसे यहाँ पे at 2d lambda by b into 1.22 you get a dark circular ring of that radius. So that's the idea. Fringes now become circular rings if the slit is basically a circle of diameter b. Diameter b. Similarly, if you use a lens to focus an image, okay, in what we learn now is that the image formed is not a perfect point sized image. Okay? The lens is also going to behave like a aperture, and the image formed has a diameter of 1.22 d lambda by b, as a radius of 1.22 d lambda by b. So if b is big, this radius is small. Okay, but if b itself is small, if the lens is not very big, then this radius becomes more and more prominent. So you can't use very small lenses, because then that creates instead of localized image, you get a spread out image. So if you imagine, if you're seeing an object which has multiple points, if each point ka image is going to be hazy and is going to mix with the neighboring points image, then the result that you will see will not be a bright, clear, good resolution image. Okay? So you don't want neighboring points ka image to coincide or overlap in that sense, or disturb the neighboring point. And that's, otherwise it will appear blurred. Yeah, and that's what we mean by poor resolution. So Riley का फिर ये criteria था कि you consider the images to be just resolved if दो points के बीच में जो distance बनता है that is just the radius. Okay, that's equal to the radius of the size of the bright disk that will be formed. तो 1.22 d lambda by b इतना डिस्टेंस होना चाहिए उन पॉइंट्स के बीच में, तो रेडियस के बराबर डिस्टेंस होना चाहिए. अगर पॉइंट्स आर क्लोजर देन दैट रेडियस, then they will overlap and you say it's unresolved. ठीक है. And of course, if the distance is more than that, then it's good, it's well resolved. Okay, but just to resolve, the limit of resolution is when the distance between them is equal to the radius of the bright disk. Okay, and with that you get the resolving power and all of the telescope. I have seen this derivation. The ultimate idea is finding the widest angle. Okay, मेंस के लिए प्लीज यार ये थोड़ा अच्छे से देख लो. तो the widest angle, the angular separation between two objects that are just resolved using the telescope. Okay, that angular separation, वहां पे जो एंगल होगा वो इस साइड भी सेम एंगल होगा. ठीक है, इस साइड भी सेम एंगल होगा. एंड देन दैट एंगल इज दिस डिस्टेंस बाय रेडियस. और यहाँ पे रेडियस, ये डिस्टेंस इज बेसिकली योर फोकल लेंथ, एंड दैट डिस्टेंस बिटवीन देम इज 1.22 d lambda by b. एंड d अगेन क्या है? d is again distance of image from the aperture, so that's basically the lens itself. So ये भी 1.22 f lambda by b हो गया, और दूर है इसलिए ये फोकस पे बन रहा है. तो बेसिकली डेल्टा थीटा, I just went over this. ये फिर भी easy derivation था थोड़ा सा टेलीस्कोप का, so you can remember this. But result either way derivation, ये तो don't want to remember that, that's fine. But result याद कर लो. So delta theta, angular separation is 1.22 lambda by b, and reciprocal of that angular separation is what resolving power is defined as. Okay, so resolving power of telescope is b by 1.22 lambda, and that's why, as we said, small apertures create problems. They create hazy images. Large apertures, this why is why this is why large apertures are preferred for telescopes. That's how you can get a well resolved image. Resolving power of a microscope. We won't go into the derivation. In fact, you can't exactly derive this result. If you read this derivation also, you realize you can't exactly derive the result based on what we know at this stage. But I would just say just remember the results. The result, first of all, there is this nearest distance. Okay, the closest 2 points can be on an object, so that the microscope can distinguish them as different. Okay, so the microscope can distinguish them as different. So the closest 2 points can be on an object, that is delta d, और उसका formula है 1.22 lambda by 2 mu sin theta, and उसका reciprocal है the resolving power of a microscope. So 2 mu sin theta by 1.22 lambda. Okay, sin theta इसमें, theta is basically the half cone angle subtended by the the lens on that object. So that is theta, the half cone angle subtended by the lens on the object. Either they give you theta and all directly and give you mu, or they may tell you the value of numerical aperture. When they do that, you should know what numerical aperture is. So mu sin theta is called as numerical aperture. So ये तो वो directly दे देंगे. That's good for you. So again, there's a question on a telescope and a microscope that you can try out. Fresnel distance, not very important, but basically b square by lambda. If you're at a distance less than b square by lambda from a slit, okay, or from a lens, okay, then if you're at a distance lesser than the value, then ray optics के results are valid. Ray optics more or less dominates. Okay, you can say the image formed are more or less point sized. But if you are at a distance greater than the Fresnel distance, then diffraction dominates. Okay, B is the beam diameter, or basically the aperture diameter. Same convention as before. So the aperture diameter that it passes through. Okay. So lambda is in nanometers, and if d is decently big, maybe centimeters mein vagera hai, so then you could say that this distance is big. So therefore, you technically your Fresnel distance is decently big. Okay, so therefore, when you use lenses for practical applications and all that, diffraction का उतना ज़्यादा problem नहीं आता. But problems arise when you start to use smaller apertures. Smaller apertures, and the distances involved become bigger. That's when you leave the world of just simple ray optics, and that's when diffraction also comes. Anything else over here? Polarization, I think simple. Let's summarize it with that law of Malus. तो वो क्या बोलता है कि basically when light passes through a Polaroid, when it gets polarized for the first time, intensity becomes half. It gets polarized for the first time, intensity becomes half. On the other hand, when already polarized light passes through another polarizer, then intensity becomes I into cos square theta. So if the new polarizer ka transmission axis makes an angle of theta with the original plane of polarization, okay, then only I cos square theta remains. The idea is E cos theta remains. This is current I cos square theta intensity remains. Okay. तो subsequent polarizer से जब पास करेगा, first अगर unpolarized है पहले ही आधा हो जाएगा, फिर into cos square of this angle हो जाएगा, फिर into cos square of that angle हो जाएगा. Okay. So try that. Try this question out as well. What else? Polarization by reflection and refraction. So we said that the reflected ray is heavily polarized in the horizontal direction, and the which is basically parallel to this plane, and the perpendicular to our screen, and the refracted ray is heavily polarized in the plane of the screen. In the plane of the screen, and as such perpendicular to this plane, perpendicular to the surface का plane. ठीक है, उस direction में polarize होता है. And basically उसमें what we see is so there will come a special angle called as the Brewster's angle, जिसमें ये reflected ray completely polarized होगा. तब उसमें वो वाला component नहीं होगा. In that Brewster's angle वाले situation में the reflected ray and the transmitted ray are perpendicular. Okay, this entire law describing this is called as Brewster's law. And Brewster's angle of incidence mein, you can see how this angle is beta. This is also beta. So this becomes 90 minus beta. Okay. And then mu is sin I by sin R. So that becomes sin beta by cos beta. And mu becomes tan beta. So that Brewster's angle relates to the refractive index by the formula beta is tan inverse mu. And that's it. That's it. And then you have Huygens law, which I'm sure you guys are familiar with. Huygens में जैसे ये क्वेश्चन ऐसा मैंने पूछा था, just try this out. इसमें watch out. यहाँ पे Huygens construction में what you see over here are not the rays actually. Huygens construction में what you see, whatever lines you see, they are wave fronts. So that's where you have to be careful. Okay, so the actual ray is perpendicular to the wave front. So यहाँ पे angle of incidence ऐसा होगा और angle of refraction ऐसा. Okay, so try this question out as well. And in the limited time that you guys probably have, just I would say good revision is, yes, you can keep doing new questions, But I think it also makes sense to go back to at least the level you were at when you learn this topic. It makes sense to revise what you already learned. So at least with the class questions, and if you were solving some book at that time and you have solved good questions, revisit those, revisit your learning from those concepts and those questions from time to time. Okay. All right. See you guys again, I think, tomorrow. Bye bye. So since I have my boards and mains first exam, both in March, which should I prioritize? I would say, I mean, do your boards well. You get only one attempt. Um, at least try to get 80%. Okay, so do your boards well. If it's just 1 week away, one month away, and if you haven't studied yet, then I would say start studying. At least अभी मतलब एक हफ्ता करके देखो, see how much you can cover. If in one week of preparation you prove to yourself कि अरे I can prepare very fast, मैंने सब गाइड वगैरह जल्दी पढ़ लिया, I'm in a way ready for the boards, then well and good, you can थोड़ा side by side हाथ लगा सकते हो जेई का. बट अगर तुम ये 1 week मान लो पढ़ने बैठे एंड यू रियलाइज कि ज्यादा कुछ हो ही नहीं रहा है, बहुत धीरे धीरे हो रहा है, और इट्स टेकिंग टाइम, और सम थिंग्स आर न्यू एंड डिफिकल्ट टू अंडरस्टैंड, then I would say please devote the rest of the time for your board exam. You have worked hard for your mains exam all this while. Okay? You won't forget things. um, there's no miracle also you can do right now by studying एकदम एक्स्ट्रा हार्ड फॉर द मेंस एग्जाम. एक दो हफ्ते में ज्यादा कुछ जादू नहीं करोगे, तुमने जो भी मेहनत करना था तुमने कर लिया है. बस you just need to revise from time to time. You get those pockets of time where you are bored studying for the boards, you want to revise, you could try revising a little bit. But boards एक बार I feel अगर अच्छे से कर लिया, you will still, if not the mains first exam, you will still have, decent time for the subsequent mains exams. So you'll have time, so don't worry. Boards wala अच्छे से करो. Okay. Yeah. Welcome. Bye bye.